Hello, my name is Alexa Samara Muñoz Castañeda, and this is the Team 9. And now we are going to talk the subprogram control. Mm. Today, I will talk about a very important topic in programming. This is the program control and how it helps us to create, organize, and efficient code. In this presentation, we will explore key ideas like how to programs, la, ha- like how to programs works, and how data is managed, and how we can share information between methods. The goal is to understand how these tools help us to solve big problems and simple and structures away.
The subprogram sequence control. Number one, simple code return subprograms. Subprograms or functions, procedures, encapsulate a block of code that performs a specific task. When call control flow, transfer to the subprogram, and upon completion, it returns to the calling point. Advantage, maintainability, breaking complex tasks into smaller units, and code reusability. The same subprogram can be called multiple times and reducing duplication. And this is an example of the code. Recursive programs. Recursive programs allow problems to be solved by dividing them into simpler subproblems. It's crucial to have a base condition to stop the recursion to prevent stack overflow. Performance considerations. Recursion can be inefficient. And due to repeat calculation optimizations like memorization and can be beneficial. And this is the example of calculating Fibonacci. The Pascal forward declaration. Use of forward declaration especially useful in case where subprograms are recursive or when a subprogram needs to refer to another that has not yet been defined. And this is the example. And continues my teammate.
Let's talk about attributes of data control. To begin, let's talk about names and reference environments. Names serve as identifiers for variables, functions, and other elements in code. The references environment determines where and how this name can be used. These concepts help programmers understand variable accessibility, avoiding errors caused by undefined or ambiguous reference. Static and dynamic scope. Next, we explore static and dynamic scope, two case models for variable resolution. Static scope, variables that are resolved based on their location in the source code. This predictably avoids confusion and enhances code reliability. Dynamic scope, variables that are resolved according to the sequence of subframe calls, while flexibles, this can lead to errors if not managed carefully. Each scope model has its applications, but understanding this distinction is critical for preventing bugs. Block storage. Another significant attribute is the block storage. This allows us to group declaration within a block, controlling variable visibility and improving code organization. Think of it as a way to ensure that data is only accessible where it's intended to be, enhancing modularity and security. Local data and reference environments. Lastly, local data and reference environments pertain to variables defined within the subprogram. These variables are exclusive to the subprogram's safeguarding data integrity by preventing unintended modification from outside.
Parameter transmission. Actual and formal parameters. Actual parameters. The real argument passes during a method call. Formal parameters. The parameters declared in the method definition. ¿Qué quiere decir esto? En el actual parámetros, es como esto de aquí arriba, donde es la función con solo variables, sin datos en sí. Y los formales, los parámetros formales, vendrían siendo como la parte de aquí abajo. Ya viene con un valor en sí. Por ejemplo, aquí solo decía A y B. Aquí abajo ya dice 3 y 5. Métodos for transmitting parameters. Por valor. Java always passes parameters by value for primitive types. This means copying the value for objects. This means copying the reference to the objects. Por referencia. While you can pass by reference in Java for primitives, you can achieve similar effects by passing object reference. Hay unos cuantos más, pero aquí no los abarcamos completos, pero estos dos son los más importantes. Transmisión semántica. In Java, transmission semantic dictate that the method receive a copy of the actual parameter value. For objects, the reference is copied, allowing modifications to the object properties. Básicamente que para los objetos, solo para los objetos, la referencia es copiada y habilita que el modificar las propiedades de los objetos. Implementación de parámetros de transmisión. Aspectos de la implementación. In Java, the implementation is straightforward, but is essential to understand the implication of passing objects reference versus primitives.
Now let's talk about an important part of programming, explicit common environment. Uh, First, no, this explains how and where variables can be used in a program. First, let's look at dynamic scope in this type of scope. Variables are visible based on the order of method calls during the program excursions. However, Java does not support dynamic scopes because it can create confusion. Instead, Java uses static scopes. This means variables are visible based on their location in the code. Static scope is predicate and eraser to control. And finally, we have block structure, which allows us to group variables and declaration inside methods or functions. This keeps variables safe and prevents conflicts by limiting their access. Uh, in short, controlling the environment of variables helps us avoid errors and keep our code organized. Now I'll talk about the conclusion. To finish, let's review what we have a conclusion, and this is um, we also saw how understanding variable scopes, whether static or dynamic, helps us avoid errors and keep control over our programs. Finally, we talk about how parameter transitions allows us to share information between methods while keeping everything accurate. These ETS make our code clearer and more relevant, especially for large projects. And this is all. Thank you for your attention.